started. This is a continuation of the lesson from Friday. So before we work out more questions, let's look at the formula sheet. This is the formula for exponential function. A is the initial value, B is the base, and then X is the variable. Alright? It has been several days already, so I would suggest you guys to look at the first two examples that we work out on Friday to brush up your memory before you proceed. So if you look at this one, so hope you have your graphing calculator with you. So if you look at this one, it's just simple graphing question. So if you graph it, so it would look something like this. Of course, put the arrowhead, and also hope you still remember that there is a horizontal asymptote here. So for this part of the graph, it may look very close or even touching the x-axis, but it never does, just that you know. All right, so that's it for this question. So now let's look at question 2a. Find the exponential function that models the graph below. So obviously we will be using this formula here. Y equals to ABX. So in this case, we have to find out what is the A and the B so that we can figure out the function. And if you look at the graph here, we call the lesson from last day that if your look for the y-intercept. So in this case, your y-intercept is 1. So what does that mean? That means your A is 1. All right? So 1 done, we still have to figure out B. There are 2 ways we can figure out B. So the first way is to just do it the algebraic way. So let's do it the algebraic way and then I'll show you the other way. If you look at the graph here, the graph is going down, so that means decay or decreasing, whatever you call. So that means you would expect a B value the B value to be somewhere between 1 and 0. Remember on Friday we talked about that. We do not use less than or equal to or greater than or equal to. Look at the notes for y. I'm not going to repeat myself here, but it is B is greater than 0 and B is less than 1. Alright? So if you apply this formula here, y equals to, in this case, A, we know that is 1, so the only missing is the B. Right? So if you randomly pick a point, of course you pick a good point. So there are many points suggested on the graph. You can pick this point here, or this point here. So if there are no objections, I'll just pick this point. It's just my personal preference. You can pick any other points, but don't put the same point here that we used this point already. So let's use -1 and 4 here. So pick this point. -1 and 4. Plug that in for x and y. This is your x, this is your y. Now plug in -1 for x and 4 for y. So 4 equals to b raised to the power of -1. So if you rewrite that, that means it is the same as 4 equals to 1 over b. Alright? So if you do the algebra, that means b is equal to 1/4. If this way is too hard or doesn't make sense, then let me show you a second approach, which is a graphical way. So if you look at this one here, this one is -2 and 16. Let's move 1 unit forward. So if you look at this is -1 and 4. So the y value now is 1/4 of the original value. So if you move 1 unit ahead, -2, -1, and 0. So in this case, look at the y value. This is now 1, which is 1/4 of the original value. So what does that tell you? It tells you that the b is 1/4. So you get the same answer. All right? So now we figured out b. All we have to do is plug in the b value back into this equation here. So y is b, which is 1/4 raised to the power of x. Like that. Alright, so let's keep going. Try outbeat yourself first before you play this video. Alright, so anyway, assuming you have attempted this question yourself. So if you look at this question, just like last question, it's exponential stuff. So we need the formula once again, y equals to a times b raised to the power of x, right? So in this case, we need to figure out the a, b values so that we can have an equation. So again, I hope this becomes your second instinct to look at the y-intercept. So if you look at the y-intercept, in this case, it is 1 again. So what does that mean? That means a in this case is 1. So the only thing we have to figure out is b. Alright, so now our formula is just y equals to bx. So again, just like the last question, we can use some of the given point, either this one is fine as well, but not this one. If you're not sure why, just plug in 0 for x and 1 for y into this equation, then you find that you have 1 equals to 1, which doesn't get you anywhere. So as I mentioned for the last question, we already used this point, so we can't use this point anymore. So if there's no objection, then I'll pick something easy for myself. Let's pick 1 and 5. So pick a point, in this case 1 and 5, and in this case you are going to substitute 1 for x and 5 for y. Okay, now plug in these values into the new equation because we already figured out a. So 5 for y, 5 equals b raised to the power of x. My b is what I'm trying to look for, and x is, in this case, 1. So if you plug that in, that means b is equal to 5. Sorry, I forgot to mention that if you look at this graph here, you can see that the graph is increasing, going up. So therefore, you would expect the b value to be greater than 1, which is either you call that increasing or going up, and preferably we call that growth. Alright, so now we figure out b. So if we just write down or substitute 5 for b, then our equation is 5 equals to 5 for b, and then your unknown, your variable is still x, so this is the equation. Alright, so again, if you're seeing Cheng, this is confusing, I don't get it, so what you can do is look at it graphically, just like what I showed you before. So if you look at this is 0 and 1. Let's go up by 1 in the x value. So now look at this one. This is 1 and 5. Look at the changes in y value. It goes up by 5. Let's go up by 1 unit in x from 1 here to 2 here. And look at the changes in y value. It goes from 5 to 25. So 1, 5, 25. As you can see, I increase the x value in a constant manner, but then the y value goes up by 5. So what does that tell you? That means the b value is, once again, 5. Alright, next question. So if you look at this one here, so the first thing that should come to your mind is, if your graph is decreasing in value, so it is exponential decay. So have a look at the question. Now let's look at part A. What is the initial mass of radium? So initial mass, if you use what you learned from science and physics, initial means the time would be 0. So if you look at this, when time is 0, and by the way, sometimes using a ruler would help you answering some math problems. May not be algebraically, but at least graphically. So if you look at question A here, what's the initial mass of radium? So that means time is 0. So as you can see, when time is 0, the amount is 1.0 grams. Don't forget the units. So 1.0 grams. Not just 1.0 grams, you might want to make a note. This is also the y-intercept. What does that mean? This gives you the A value. We may or may not need this for the rest of this question, but at least just give you a heads up that we already know the A value. Okay, so let's keep going. Now let's look at question B. What is the domain and range of the function? So I hope this is a review for you. Domain means the x stuff, the horizontal stuff. So if you look at this graph here, it goes from 0 all the way to infinity. All right, so in this case, for the domain, let's use the full notation. So the domain is x greater than 0. So domain is x greater than or equal to 0. Because if you look at this, x can be 0. All right, and then x could be any real numbers. Next, let's look at the range. Range means the vertical stuff, the y stuff. So if you look at that, this is the largest value y could be, which is 1. And then y, as time goes by, would get smaller and smaller. But once again, hope you still remember, there is a horizontal asymptote. So the graph could never be touching the x-axis. So that means the y value has to be greater than 0, not greater than or equal to 0. So the range is y is less than or equal to 1, but then y has to be greater than 0. It cannot be 0, once again, because the graph will never touches the x-axis. All right? Then y e r. Okay, so for part C, what is the decay model that relates to the mass remaining to time? So basically what they're asking is, what is the formula? All right, so in this case, always a good habit to write out the whole thing. Y equals to a b x. So on the diploma exam, this is what they like to do for written response question. They give you A, then B, then C. So if you look at this, if you screw up from part A, we already figured out what A is, which is 1. So knowing that A is 1, so that's easy. That means Y is equal to BX. And let's figure out B. So before we figure out B, by looking at the graph, you can see that the graph is decreasing, or you may call, using the proper term, decaying. So that means you would expect a B value to be somewhere between 0 and 1. So B, in this case, less than 1 and greater than 0, because it is a decay. All right, so just like other questions we did before, if you look at this here, we can do it graphically by using a ruler if you want, but this time you can try this yourself by using a ruler, but again, I'm going to show it to you algebraically. So if you look at this, again, let's pick a point. So don't use the y-intercept. So this one should be a good point because the numbers are nice. So let's pick 1 and 0.5. So pick 1 and 0.5. You can pick other points just that you know. So in this case, my x is 1, my y is 0.5. And if you plug in 0.5 for y, 0.5, and then of course we don't know the b value, so that's what we're looking for, and my x is 1, so basically my b is 0.5. Alright, so now I know my b. That's easy. Just plug in the b value back here. So y is 0.5. If you want, you can put down 1/2. That's equally fine. 0.5 raised to the power of x. Or if you want, 1/2 raised to the power of x is also acceptable because they are the same thing. Alright, so let's keep going. Question D, how long will it take for the sample to reduce to 1/20th of its original mass? So if you look at part C, we already figured out the equation. Y equals to 1/2 or 0.5 raised to the power of x. So in this case, basically we just do some substitution here. So if you look at this number, that means our current value is 1/20th. So 1/20 equals to 1/2 raised to the power of x. So if you look at this here, unfortunately, this is the beginning of the unit, so I have not taught you guys anything about solving something like this algebraically. So at this point, you can do it graphically. In the future, once you learn how to do the algebra, you can solve a question like this algebraically or graphically. So if you take out your graphing calculator, and I hope you still remember how to solve things graphically. So plot this one here as one graph, plot this one here as one graph, and then find the intersection point. So you may want to pause here. And another way is you can manipulate this, either move this one to the right or move this one to the left, so that one side is equal to 0. In that case, you just plug in one equation and then find the x-intercept at 0. So you might want to pause for a second here. Alright, so in this case, I personally, as I told you guys, I personally prefer to plot this side as a separate graph, plot this side as a separate graph, and then find the intersection point. So if you look at your graphing calculator, the intersection point would be 4.32 and 1/20th. Of course, you can convert this value into decimal, but like the value we are looking for here is 4.32. Is that the final answer? I want you guys to think about this. So I hope you guys realize that this is not the final answer. Why? Have a look at the question. Radium has a half-life of 15 days. So if you look at this, initial amount 1.0 grams, and then next one just 1 unit apart horizontally. For the y value, this is half of that. Another one, look at this, 0.5 and 0.25. So this is half of that, and this is half of that. If you look at the time period, each one, 1, 2, 3, 4, 5, represent 15 days interval. So that means going from 0 to 1, that's 15 days already. That's 15 days already. Going from 1 to 2, another 15 days. So for your answer, which is 4.32, that means 4.32 of 15 days interval. Alright, so you take 15 times the answer that we just figured out, which is 4.32. So make sure you read the question. So therefore, if you take our answer 4.32 times it by 15 days, that will give you 64.8 days. Alright, so this is all the questions we have for this section here. So you have the exact same thing. Alright, have fun trying out those questions.